Hi, in this lecture, we'll be talking about advanced data modeling. After completing this chapter, you will be able to describe the main extended entity relationship model constructs and how they're represented in ERDs and EERDs. Use entity clusters to represent multiple entities and relationships in an entity relationship diagram. Describe the characteristics of good primary keys and how to select them. And apply flexible solutions for special data modeling cases. Now, we have already seen the entity relationship model, but there are some cases where the entity relationship model is not sufficient to perfectly capture what it represents in the real world. So, for that matter, we have the enhanced entity relationship model or extended entity relationship model, which is a result of adding more semantic constructs to the original entity relationship model. For this matter, we're going to make use of extended entity relationship diagrams for the EER models. Now, we already know what entities are. Sometimes there are entities that are subtypes or supertypes of one another. The entity supertype is the generic entity type related to one or more entity subtypes and contains common characteristics, whereas the entity subtype contains the unique characteristics of each entity subtype. How do we determine if we need to use entity supertype or entity subtype in our ERD? First, there must be different identifiable kinds of the entity in the user's environment. And the different kinds of instances should each have one or more attributes that are unique to that kind of instance. If you are not getting or storing one or more attributes for that particular instance only, you do not need to apply entity supertype or entity subtype. Entity supertypes and subtypes are organized in a specialization hierarchy. It depicts the arrangement of higher-level entity supertypes and lower-level entity subtypes. The relationships are described in terms of is-a relationships, and the subtype exists within the context of a supertype. Every subtype has one supertype to which it is directly related. However, supertype can have many subtypes. The specialization hierarchy provides the means to support attribute inheritance, define a special supertype attribute known as the subtype discriminator, and define disjoint or overlapping constraints and complete or partial constraints. Let's take a look at this example. Here we have the ERD for an airlines company, wherein usually we only have the employee and the dependent. However, in an airlines company, there are certain types of employees, such as mechanic, accountants, and pilots. We've identified earlier that we need to use entity subtype and entity supertype if we have some attributes, one or more attributes that we would like to collect only for those special types of employees. And in this case, we have created entity subtypes of employees for the accountant, mechanic, and pilot because we are trying to collect some more attributes to them. For the accountant, we're collecting act title, accountant CPA date, wherein they got they're registered for accountant for being an accountant. For mechanic, we're getting their mechanic title and certification. And for the pilot, we're also trying to store their license ratings and med type. Now, why do we need to create subtypes for these employees? This is because if we are going to add these attributes to our employee table, so just having one employee table for everything or everyone, we are going to have a lot of nulls for those employees that are not mechanic, accountant, or pilot. So in this case, we have employee entity as our supertype and the pilot, mechanic, and accountant as our subtypes. It is important to note that the subtypes, the primary key that you have, is the same as the primary key that you have for the employee supertype. There are other components in this specialization hierarchy, but we will be discussing them along our discussion later on. One property of specialization hierarchy is inheritance. Inheritance enables an entity subtype to inherit the attributes and relationships of the supertype. All lower-level subtypes inherit all attributes and relationships from its upper-level supertypes. All entity subtypes inherit the primary key attribute from their supertype, as we have seen in our previous slide. Entity subtypes inherit all relationships in which supertype entity participates in, and at the implementation level, supertype and its subtypes maintain a one-to-one relationship. Here we have an example of specialization hierarchy with multiple levels. As you can see, our entity supertype is person, and there are entity subtypes employee and student. But for the employee, we also have entity subtypes administrator and professor. For the student, we also have entity subtypes graduate or undergrad. But it's important to note that all of the relationships that you have above in your entity supertype are inherited by the entity subtypes. One of this is the person. The primary key is PID. If you will notice, all of the primary keys in the entity subtypes that follows below are also PID. Also, notice that in the employee entity, we have a relationship with office, meaning an employee can have or not have an office, and an office can have multiple or no employees at all. Now, since we have an specialization hierarchy, the administrator and professor entities also inherits that that relationship of employee to the office. So when you talk about administrator or professors, you can also talk about them having an office. However, since the office is only related to the employee, you cannot talk about offices for the students or the graduate or undergrad, or even persons. Next thing that we're going to discuss is subtype discriminator. The subtype discriminator is the attribute in the supertype entity that determines to which entity subtype the supertype occurrence is related. The default comparison condition is the equality comparison, and in some situations, the subtype discriminator is not necessarily based on an equality comparison. Let's take a look at an example. In this slide, we can see several examples of subtype discriminators. We have P is M, P is 2, M is admin, or M is prof, and student type. As you can see, in some cases, you have multiple subtype discriminators. In some cases, you only have one. There is a difference between the two. If you have an overlapping constraint over here, it means that a person, your entity supertype, can be both an employee and a student, which makes sense because if you have an employee that is also a student in the university, then they would both be employee and student. So you would have to have different subtype discriminators for each of them, wherein the value for P is M is 1 or yes if they are an employee, and the value for P is 2 if they are a student, 1 if they are not a student, 0 or yes or no. But if you only have if you have a D, which is a disjoint constraint, means that you only have to be either of the two, either a graduate or an undergrad in this case. So because of that, since you can only be one of them, you only need to have one subtype discriminator, which is in this case the student type. Student type would have the value of graduate if they are a graduate student, or undergrad if they are an undergraduate student. So in the disjoint subtypes, they contain a unique subset of the supertype entity set. They are known as non-overlapping subtypes, meaning you can only be one of them and you cannot have an overlap between the two. The implementation is based on the value of the subtype discriminator attribute in the supertype. Whereas overlapping subtypes, it can contain non-unique subsets of the supertype entity set. The implementation requires the use of one discriminator attribute for each of the subtype. Here we have an example of possible scenarios that we may have. For the professor and administrator, if the value of M is prof is Y and the value of M is ADM is N, make sure it means that the employee is a member of the professor subtype, but not necessarily an administrator. If the M is prof is N, whereas the M is admin is Y, means that the employee is a member of the administrator subtype, but they are not a professor. If they are both Y, M is prof is Y, and M is ADM is Y, then they are both employee and employee that is a professor and an administrator. And that's what we mean by overlapping. So we can have either disjoint or they can also overlap. They are both professor and administrator. Next is the completeness constraint. The completeness constraint specifies whether each supertype occurrence must also be a member of at least one subtype. For this, we have partial completeness, wherein not every supertype occurrence is a member of a subtype, or total completeness, wherein every supertype occurrence must be a member of at least one subtypes. In our diagram in the previous slides, the partial completeness is specified by um, one line. The total completeness is specified by 2 lines. We will be having a discussion and an example later on. So the following are the possible combinations that we may have when we talk about the completeness constraint. and the disjoint or overlapping. If we have a partial disjoint constraint, it means that the supertype has optional subtypes, the subtype discriminator can be null, and the subtype sets are unique. If you have a partial not overlapping constraint, the supertype has optional subtypes, the subtype discriminators can be null, and the subtype sets are not unique. If you have a total disjoint constraint, then every supertype occurrence is a member of only one subtype. The subtype discriminator cannot be null, and the subtype sets are unique. And lastly, if you have a total overlapping constraint, then every supertype occurrence is a member of at least one subtype, and the subtype discriminators cannot be null, and the subtype sets are not unique. Now let us differentiate specialization and generalization. Specialization is the top-down process. We are identifying the lower level, more specific entity subtypes from a higher level entity supertype. And this one is based on grouping unique characteristics and relationships of the subtypes. For generalization, this one is the bottom-up process. We identify a higher level, more generic entity supertype from lower level entity subtypes. And this one is based on grouping common characteristics and relationships of the subtypes. Now, to apply the concepts that we have just discussed, I'll let you answer this one on your own and discuss with your classmates in the discussion board portion of our Blackboard.